Hello and welcome to yet another video where we continue looking at concepts which are examined in Mechanics 1. What is the aim of these sessions that I'm releasing now? The aim of these sessions is to help you to be able to understand how certain concepts are usually examined in these particular examinations. And today I'm going to look at question number 3. So let's go straight to it and see what it entails, and then I'll be able to describe the various concepts as they unfold. Welcome. So let me go to the actual question itself. What are we told here, or what are we given? We are given that 4 coplanar forces, and before I go very far, coplanar forces are forces which are in the same plane, maybe in the horizontal plane, vertical plane, inclined plane, something like that. You should be able to understand the meaning of that term, because that term appears from time to time. Coplanar forces in the same plane. Okay, we've got 4 forces of magnitude F, 5 newtons, 25 newtons, and 15 newtons are acting at a point P in the directions shown in the diagram. Given that the forces are in equilibrium, this is the point. The forces are in equilibrium, because you must always pay close attention to the state of the system. Because once you understand the state of the system, then you're able to know which concepts to use. When you are given this type of question, there could only be 2 states. The system is either in equilibrium, or there is a resultant force on the object, or in the system there is a resultant force. In this particular question, the system is in equilibrium. So let's see what concepts we are supposed to use when the system is in equilibrium. And straight away, without wasting time, any system of forces which is in equilibrium, the resultant force in that system is 0, or the resultant force which is acting on the object is 0. So this is one of the concepts which I'd like you to understand. How does it come about? They will mention that word equilibrium. When they mention the word equilibrium, you're supposed to know what it means. If the system is in equilibrium, then it means that the resultant force, when you add all the forces, you're going to get 0. Now, there is a process that we always follow when we want to work out this kind of question. Okay, we are supposed to find the values of F and alpha, F and the angle alpha, and this is what we have there. Now, you're going to also remember that when you're given a system of forces, such as the one you're given here, and the forces are not, some of the forces are not in the standard directions. I mentioned this term, standard directions, in the first question. What are the standard directions? The standard directions are horizontal, vertical, parallel to the incline, perpendicular to the incline. In Mechanics 1, those are standard directions. If a force is not in any one of those directions, then you're supposed to resolve that force. For example, here we find that F is not in the vertical direction, it is not horizontal. So we are supposed to resolve it in such a way that we get one component which is horizontal, the other component which is vertical. Second point, when you resolve a force, you always resolve it twice. Whether you are going to use the second component or not, make it a habit that when you resolve a force, always resolve it how many times? Twice. And the 2 directions in which you resolve that force must be perpendicular to each other. Resolve every force twice, and the 2 components must be perpendicular to each other. Next, if you're given a vector, because a force is a vector, and you're supposed to find its component in a particular direction, that component will always take a cosine. So you're going, like for example, to have this one will have a component in this direction, and its component will be F cos alpha. And then the other component will be perpendicular to that in this direction in such a way that the force which is being resolved is in between them. Because somebody can say a direction like this one is also perpendicular to this component. How comes you are saying that the second component must be perpendicular and it must be in this direction? How do I know? How do I know in which direction the second component is supposed to be? It's very easy. The force which is being resolved, or the vector which is being resolved, is always in between the two components. So the first component will take a cosine because that component makes an angle theta or alpha with the vector. And then the other component is perpendicular to it, which will be f sine alpha. The other force which is not in the standard direction is this one. So one of its component will be this one, which will be 15 cos 20. And the other component will be here, which will be 15 sine 20. You can see how easy it is. So there are steps. And when you go through this video once again, you'll find that I have outlined these steps. Make sure that you understand those concepts which I say this is important. You should always remember it. For instance, I've already talked about the state of the system. Always be careful to identify what is the state of the system so that you can know where to start. You've been told the state of the system is such that the system is in equilibrium. The forces are in equilibrium. That means the resultant force is zero. And then the next question would be, how do we solve a question that has got so many forces in different directions and you are told that the resultant force is zero? Very simple. The reason why we are resolving in two directions which are perpendicular to each other, horizontal and vertically, the reason why we are doing that is so that all the forces will either be in the same direction, right in opposite directions, or perpendicular to each other. And this is what we mean. And before I go to the next slide here, I'd like you to identify that the forces which are in the standard directions, we don't resolve them. We leave them as they are. Don't touch them. Don't touch 25 newtons. Don't touch the 5 Newton force. You can see when it comes to solving these questions, it is so easy. It is so easy. And when you go through some of the examples that I will give you in the video description, requiring you to attempt them, you'll find that if you follow those methods, it will just, everything will fall into place and you'll find mechanics will become one of the easiest papers. The reason why mechanics becomes a little bit challenging to most students is because they really don't know. They don't have those clues, what to look for when they are given a certain question. So this type of question where you're given several forces, some making an angle with a given direction and some in the standard directions, and then you're either told there is a resultant force or there is the forces are in equilibrium. There is a standard method of solving that. Identify the standard directions in the question. Is it such that the object is on an inclined plane, in which case the standard directions will be parallel to the incline and perpendicular to the incline? Or is it in such a way that here I can obviously identify that the standard directions are horizontal and vertical? Is it such a situation? And then you go ahead. So remember, forces which are in the standard directions, we do not touch them. We leave them as they are. So if we go ahead and resolve these forces, this is what we are going to get. The component of F horizontally will be F cos alpha. And its other component in this direction will be F sine theta. One is always a cosine, the other one is always a sine. All right? And you find that now I'm going to add 5 plus F cos alpha. right, in that direction in order to get the resultant force to the right will be F cos alpha plus 5. When I come to the 15 Newton force, I will resolve it in this direction and get F cos 20. And then perpendicular to that, I get 15 sine 20. Right? Then the sum of the forces to the left will just be F cos 20. Okay? While the sum of the forces to the right will be 5 plus F cos alpha. And then next, the sum of the forces vertically upwards is F sine theta. Sum of the forces vertically downwards is 15 sine 20 plus 25. Now, after you have resolved all the forces in the standard directions, like we have done here, then you are ready now to equate the sum of forces in one direction is equals to sum of forces in the opposite direction. Okay? Make sure before you go to that step, you have resolved every force. For instance, this force is no longer there. This force is no longer there because this force is represented by its two components. And this force is also represented by its two components. After you have done that, this is what you're going to get. You see? You make all components or all forces to form some kind of a plus sign, so that now you can say, since the system is in equilibrium, the horizontal forces can be treated independently of the vertical forces. I'm going to repeat that because it's very important. You see, all these forces, they are either acting in the same direction or right in opposite direction or perpendicular to each other. When that is the case, then you can treat horizontal forces independently of the vertical forces. For example, you can say the sum of the upward forces, which is F sine theta, is equals to the sum of the downward forces, which is 25 plus 5.130. How did I get 5.130? I got the component of 15 sine 20, which is 5.130. I add it to 25. And that is what I have here. Right? Now, also, the sum of the forces to the left is equal to the sum of the forces to the right. After that, the next step is a scale. You can see there are two forces which are unknown. After that, you need a scale here. There are two physical quantities which are unknown: the angle alpha and the force F. The step in all such questions, the step is to obtain a certain sine theta, a cos theta, so that when you divide sine theta by cos theta or sine alpha by cos alpha, you get tan alpha. So you must get one expression. For example, over here, we've gotten one expression which states that F sine theta is equals to 30.130. In other words, sum of upward forces equals sum of downwards forces. You call that equation 1. You see, you cannot solve this equation because there are two unknowns, angle alpha and F. The next is now to use the other direction. Sum of the forces to the right, which is F plus F cos alpha, is equals to sum of the forces to the left, which is 14.095 newtons. You equate them with the intention of making F cos alpha the subject, and you call that equation number 2. Now, once you have obtained these two expressions, one with a sine, the other one with a cosine, this is where the actual fun begins. What do I mean by this? You obviously know there is this trigonometrical function which says that sine theta over cos theta is equals to tan theta. Okay? And your intention is to divide this equation that carries the sine alpha by cos alpha in order to get tan theta. When you do that, you automatically realize that the F cancels out. See this F, and that is your intention. So this is a method of solving the angle alpha. Like you can see, F cancels out to give you tan alpha is equals to this value, and you can use your calculator to get alpha to be 73.2. Once now we have got the angle alpha, it's just a matter of substituting that alpha in one of the expressions. Like for example, I substituted it in the expression that carries the cosine, where I have F cos 73.2 is equals to this value, and I get the value of F. You can indeed see that solving this kind of question is very, very simple. It's very, very interesting. But there are methods to follow. If you follow this method, you really enjoy problem solving in mechanics. Problem normally comes where you know these concepts, but you don't know when to apply them. You can be able to resolve a force in two perpendicular directions, but you don't know when to apply that particular situation. My aim is to show you when to apply a given concept. So it's so important to realize these ideas. So I'd like you to go through the video once again. Note those points where I mention the concepts. Note them down in your notebook, so that in the subsequent questions or examples or practice questions which I give you, you can try to see how those concepts are going to unfold. They are going to unfold. And always be on the lookout. Ask yourself, how is this concept that I was taught unfolding? How is it unfolding in this particular question? That is what you should always be asking yourself. Because when you learn a particular concept, you are sure the examiner is going to examine that particular concept. How does it unfold in this example? So make sure that you go through the practice questions which I'm going to give you in the video description. All these practice questions, I've obtained them from past papers, so they are going to be very relevant to you as you practice for your main examinations. In addition, like I always state in every video, I have prepared a complete course at Udemy in Mechanics 1. So just click on the link, go to that particular course. You'll find that there are a number of free videos, and if you're satisfied that whatever I've taught you in those free videos is evidence that the course can be of assistance to you, go right ahead and purchase it, and you will not regret it. Because in that course, I've looked at every concept in a very keen way. I've ensured that I've looked at all these concepts step by step, leaving no doubt as to the fact that you have understood it. All right? So go right ahead, follow the link, click on it. And if by chance you are coming to this particular channel for the first time, you'll find that it is important to subscribe, so that each and every time I make a new video, you are alerted about it and you can be able to know what it is that we are talking about. Otherwise, in the next video, I'm going to look at question number 4, where I'll be outlining other important concepts. And then I give you more examples so that you can be able to practice on that particular concept. So see you in the next video.